Hi everyone, it's me, Carolyn Chapel, and this video is going to discuss random variables and lead into discrete probability distributions. Sorry, that doesn't look very well, but it is distributions. First of all, a definition. A random variable, what a random variable is. It is basically a numerical measure of the outcome of a probability experiment. And so its value is going to be determined by chance. We like to denote random variables. So I'm going to kind of put this here, random variables, with capital letters. Letters, such as, we could use an X, a Y, Z, P, whatever letters we like to use. A lot of times mathematicians and statisticians like to use the letter X. So we like that to be our random variable. I want to remind us that we do have two types of random variables. We do have things that are going to be discrete random variables, and you should have learned these terms earlier. So it's nothing new. Or you could have continuous. And we're going to start off just looking at our discrete ones in this video. The continuous ones are very important, but they will come later. So we have discrete random variables and continuous random variables. And basically the difference is what the outcome is for X. What kind of values can X take on? Can it be a discrete situation or a continuous situation? So I'm going to start with an example, one that you've probably seen in previous information somewhere. And let's take a simple experiment and let's flip a coin. Okay, and let's just do it one time to start. And when you flip that coin, we do have two outcomes. And those two outcomes are a head or a tail. So you're either going to get their head or a tail. This is not necessarily a random variable, but we can create a random variable connected to this experiment by letting, let's say X, our favorite letter, be the number of heads we see when flipping a coin. Okay, so this variable, this random variable, takes on two values. It basically takes on two values, a 0 in the case that we flip that tail, or it takes on the value of 1 when we flip a head. Okay, and what we do is we like to create these outcomes or these values associated with their probabilities. And we like to put them in table forms. And what we call this table is going to be our discrete probability distribution. It's basically putting all our knowledge about this experiment and these outcomes together in one spot. Okay, the word discrete is kind of describing what type of random variable we are. Probability is going to be because those probabilities for these outcomes is also going to be listed. And the way we like to do it is in table form to start with. And so we'll have our X value here, and then we'll put P of X kind of underneath it. And what we're going to do is we're going to list the values that X takes on. So in this case, our 0 and our 1. And now we want the probability of each of those things happening. Okay, remembering that 0 meant we got a tail, 1 meant we got a head. The probability of flipping a coin and getting a tail is that 1/2. And our probability for getting a head is also 1/2. So our probabilities are just the 1/2 and the 1/2. Okay, so this is a very simple experiment, just flipping that coin that one time. We can extend it to possibly flipping the coin 3 times. Okay, and again, this time we'll use X again. Let X be the number of heads that we obtained. Okay, and we want to, again, write our probability distribution, our discrete probability distribution. Discrete because X only takes on certain finite values. So again, I'm going to write my X, and I'm going to eventually write my P of X on here. But I'm going to have to remember how we do that. But again, we're flipping our coin 3 times. So X is going to be the number of heads that we get. Well, we could have gotten no heads out of those 3 flips because we'd gotten a tail, tail, tail. We could have gotten 1, we could have gotten 2, and we could have gotten 3. And now we have to try to remember the probability of each of those, or calculate the probability of each of those happening. And so there's a couple of ways we can do this, is going back to what we've learned previously, is we could write out our sample space, where we kind of like have our head, head, head. We could have had a head, head, tail. We could have had our head, tail, head, or our head, tail, tail. So I'm kind of writing all these samples, these down. We could have had our tail, 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 our tail, tail, head, tail, head, tail, or tail, head, head. So those are the different outcomes that we have. You can see that there are 8 of them. The probability that we had 0 of them is the fact that we got that tail, 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 which is 1 out of those 8. Similarly, 3 is the HHH, which is 1 out of that 8. Getting 1 head, let's see, there's 1, 2, 3 out of the 8. And getting 2 heads, there's 1, 2, 3 out of the 8. Okay. You could have drawn a tree to calculate all of those pieces. We could have made probability trees. So there's a number of ways to come up with these final probabilities for all of those different outcomes. But once we have them, we have that information right at our fingertips. So if someone says, I flipped a coin 3 times, what's the probability I'm going to get 2 heads? You can say, well, that's 3/8. We can also graph these, and I've seen graphs done a number of ways. So I would say to look in your textbook to see that how they do them. I've seen them done with just lines. I've seen them done with little bars. So again, check the textbook that you are using in order to graph those. But what you'll see just generically here, a real rough graph, is you'll have your probabilities on this point here. You'll have your X values, so our X takes on 0, 1, 2, and 3, and you would probably, of course, include a title, label what this X actually represents, so the number of heads that you see in 3 rows, and then you'd have little either bars or just lines, so like a dot plot almost. Or sometimes I've seen bars filling those things in. So very simple graphs. Again, it does need a title to make sure your graphs are complete, titles, labels, and scales. So I should have probably had 1/8, 2/8, and 3/8 up there. So you can kind of see that. You can look at these and we can discuss symmetry again. We can talk about things being symmetric, which this one is kind of symmetric, kind of nice, evenly shaped. We can talk about them being bell-shaped. This one somewhat has a bell. Could be skewed to the right, skewed to the left. So all of those skewness ideas also relate here. Because this is all based on probability, we do have a few rules that these things take on. So some rules for these things, or properties, if you want to think of it as another word. properties for a discrete random variable. Okay, and because these are connected to probabilities, these probabilities here, that's where the rules come into play. These X values can take on anything that you want it to, just about, depending on the experiment that you're calculating. They can be negative, they can be positive, they don't have to be in sequential. You can jump from 1 to 5 to 7. It really depends on the experiment that you are using. So, but the rules have to deal with the fact that these are probabilities. So some things to remember about probabilities is every probability has to be between 0 and 1. So you'll notice we had a 1/8, a 3/8, a 3/8, and a 1/8. All of those numbers are between 0 and 1. You're not going to see like a probability of getting 1.2. Doesn't happen because that's saying it's a certain, actually beyond a certainty. So past that. The other thing to remember is that when we add up, again, remembering this is our sigma notation, that simply does mean to add up. If you add up all of your probabilities, you should get the number 1 because you're getting the entire sample space. So when we added the 1/8, the 3/8, the 3/8, and the 1/8, we do get that number 1. And so for these reasons, you can ask questions about, well, what happens if I don't know this piece, but I know all the rest? Do I still need to calculate it? Well, no, you can add them all up, subtract from 1, and you have that missing piece. So again, all those things come into play. Okay, we're going to do a couple more examples on how we can use these discrete probabilities to answer questions. So here's another example. Let's say that a basketball player, we see a lot of probability and stuff in sports, so we like to use sports a lot for examples. A basketball player shoots 3 free throws. And we're going to let X denote the number of shots they made. Okay, so here is our probability distribution. So they've made shooting 3 of them, so that means they either made none of them, 1, 2, or 3. And of course, these probabilities kind of can tell you how good or poor of a free throw shooter this basketball player is. So let's say that this probability for this particular player is 0.01 for the 0, 0.10, 0.38, and 0.51. Okay, I'm going to kind of double check just to make sure that my rules are all satisfied. All of these numbers, these decimals here, are between 0 and 1. And if I add them up, that's going to be 0.11, 0.49. I do get the number 1. So it is a probability distribution that works. And we can use this to answer some questions. So, for example, what is the probability that this player makes 2 of their 3 free throws? Okay, and since we're saying makes 2, remembering X represents how many they make, the probability for that is right at the bottom. So that is at 0.38. You can ask another question. What is the probability that a player, or this player, I shouldn't say a player, this player, every player would have their own probability distribution. So this player makes, let's go with at least 2 of their 3 free throws. Okay, so at least 2. Here's where you have to kind of remember what the term at least, or what that phrase means. And at least 2 means that they are making 2 or more. So this would be 2 or the 3. The nice thing about these probability distributions is each of these outcomes is disjoint. There's no way for them both to happen at the same time. So I can do 2 or 3. I can take those two values and add them together. So 0.38 plus 0.51. Okay. And so this is how we can use these probability distributions to help us answer some questions. Some of the questions I will answer in a different video is, how do we find the average number this person's going to make? So if they did this over and over and over again, shot 3 free throws, on average, how many would they make out of the 3? So we calculate the mean. There are situations where, I mean, this number of choices for X gets to be too long. We don't want to write them all out. So we'll get formulas for calculating the probabilities, but that's coming. So at this point, I'm going to stop this video. And I hope you learned a little bit more about probability distributions. See you in the next video.